Helmut, thank you so much, and thank you to all who are here. I particularly want to thank the Rachel Carson Center for making this possible, Helmut and Christoph, Ariel, and all the good staff who keep things going, and to the fellows and to the junior colleagues who are here with us, and LMU and the good folks who are keeping the equipment running well. Is it okay if I begin with a quick question that Helmut already raised? And I meant to mention last week, after Ariel had sent out the note about the topic of this week's talk, the Pentagon very helpfully sent out a big report that answered that question, saying, yes, we're interested very much in climate here in the year 2021. But if we think back over the decades, what decade do you think the Pentagon really got serious about thinking about climate change? Any hands for the 1990s? No, 1980s? 80s?
I would think so.
Okay, 70s? I see a few hands. 60s? 50s? 40s? My gosh, the brave aim for the 40s. Let me begin by telling a few stories, and then I want to introduce some larger themes that are in the book that I'm writing here at the Rachel Carson Center. But I also want to raise a few possibilities for research that some of you may want to think about pursuing in future years. There's so much that's out there that still needs to be covered before we have a better understanding of how we came to know and understand climate change and military influences and lots of related issues. A quick story for those of you who just were thinking about when the Pentagon got interested. Some of you may know of this fellow, Hans Allman. He was one of the major climatologists of the first part of the 20th century, had explored throughout the Arctic, knew what the German Antarctic expedition had returned in the 1930s. And in 1947, Allman did a lecture tour in the United States, Yale, Chicago, University of California, Los Angeles, and he is raising a concern. It seems to be getting warmer. And there are consequences of this warming, one of them being many people live in coastal areas. It's going to be a big concern if the temperatures keep rising in the way that they are. This is a story in the New York Times. That much is very visible. What wasn't known at the time was that on his way back to Sweden, Allman paid a visit to the Pentagon. And this is the report. We were able to get it declassified. Allman's view on what needed to be studied about the climate. He introduces himself. He mentions that climate change seems to be caused by natural processes. But he says it is significant enough that governments need to pay attention, and he's aware of his audience. He speaks to the military saying, this is going to make it easier for the Soviets to use the North Sea route, to feed their armies, to feed their population. Climate change is a national security concern. This is a different question, and I'm just curious, as given the interdisciplinary background that many of you bring who are here. This is 20 years later after Allman's visit to the Pentagon. Don Horning, who was a chemist, he had been at Brown University before he became science advisor to President Lyndon Johnson, writes to a fellow official, and he defines the environmental sciences. aeronomy, geology, geodesy, you can see the list. Is anything missing when you think of environmental science? Yeah.
The social studies?
Social studies would be one. Others? Yeah.
Climatology.
Pardon?
Climatology?
Climatology, they're kind of getting at that with oceanography, but you're right. It's not explicitly mentioned. Any with a B word? Yeah. Biology isn't there. And there's something really important. How does that come to be? And I just wanted to put this up as a quick reminder. In the United States, there were no departments of environmental science in the way that we would recognize them today as late as 1967. There's something very interesting going on in those first decades of the Cold War period. And these are some questions that I suspect interested readers coming upon a story like this might be wanting to ask. And where I would love to hear your thoughts, your ideas, is in the larger framing of the book project in which I'm undertaking now. For climate change is a thread through that story, but it isn't the primary motivation for what these researchers are doing. It is part of their larger concern about the physical environment. But they are interested broadly in understanding how the planet works in a physical way. Why they're interested has very much to do with patronage that's coming out of the military for a very specific reason. We'll speak about that in just a moment. Why this intrigues me, and Helmut summarized it so well. How do we think about the production of knowledge? What we know, what kinds of questions get asked and pursued and funded at particular times? Which ones get sidelined, don't get pursued? It's important, it's particularly important perhaps as we confront a climate crisis in our present time. The story that I'm about to tell you is coming out of work in several dozen archives, a fortunate oral history project that captured the memories of some 60 people connected with various parts of the environmental sciences in the first decades of the Cold War. The book is going to attempt to integrate all that and get at how to tell a story of the environmental sciences in those first decades of the 20th century, particularly in the United States. Such a book has to begin with material that all of you know. 1947, the time of Allman's visit to the Pentagon, is at the start of the Cold War. And the Cold War is one in which memories of the impact of science and technology are particularly vivid. And it's not only the atomic bomb that people are thinking about, but the multitude of new developments coming out of science, technology, radar, the proximity fuse, chaff to disguise aircraft, even the forecast for the D-Day landing, all of which coming out of the physical environmental sciences, the latter ones at least, and physics. Penicillin comes out of the war as well, part of the contribution of medicine. But what really begins to shape the agenda of the Pentagon and its desire to support physical environmental sciences are these weapon systems that are not really the key for World War II, but very quickly are recognized will be central to pursuing the Cold War. Guided missiles, using developments, particularly from Germany, but now with the capacity of carrying atomic weapons, at least that is soon envisioned in 1947. Advanced submarines, aircraft carrying atomic weapons. How does one operate these new technological systems successfully? It requires an enormous amount of environmental knowledge, or at least knowledge of a particular kind. And I simply wanted to stress also that one reason that the military was so interested in Greenland and parts north was something evident if one looks at a globe, not a Mercator map, but can look down and see that the Great Circle route, the fastest way to connect North America and the Soviet Union, lays directly over the pole. One person in the Pentagon called Greenland right here the world's largest stationary aircraft carrier. You can see the way that people are thinking in this time. And it's not something that's fully secret. If one opened Look magazine in the United States, wide circulation, back in 1952, one would have seen a map looking at the perspective of Greenland, the new base that the Americans were building in Thule, and one sees the flight paths to particular parts of Europe, then into Asia and the Soviet Union, measured in terms of aircraft miles. The implications quite clear. How did this affect the Pentagon? How did it start to get civilian scientists on the physical side of the environmental sciences thinking about the big unsolved problems in their field, what they needed to know? It came out of the Pentagon. This organization chart is helpful because it shows that a group called the Research and Development Board, half civilian scientists, half their military counterparts, meeting on a regular basis every 6 months to talk together about what those big problems were and how to figure out which projects to fund. It was a major new undertaking on the part of the Pentagon. The earth sciences were number two, for a while physics because of the bomb, number one, but the earth sciences very much at the center of what the RDB was seeking to do. Another declassified document, you can see it was one secret, talking about the earth sciences. The whole field is broad, and the military applications of these sciences are numerous. It was clear that to understand how to use effectively guided missiles, submarines, one needed to know about the atmosphere, about atmospheric electricity, about the physical properties of the oceans, about the shape of the earth, the geoid as it's called. And this is a chart that came out from that same group meeting 1 year later, and it's a kind of intellectual map of the military's perception of the environmental sciences. I'm probably not giving anything away if I say the B word isn't there either, okay? It is all of the main branches of the physical part of the environmental sciences, and there on the right side, coordinated with that intellectual map, is a list of why this information is needed. And yes, that does say up here next to meteorology, the hope of weather control. All these things, if anything is interesting to any of you, we can talk a little more about it in the discussion. Here's where I find a challenge in telling this story. It is not fully a story about people coming together to explore climate change, but there is a clear understanding of the utilitarian value of knowing if the climate, particularly in the Arctic, is getting warmer. How can one do military operations if the ice is not going to be as stable as it had been in past years. And this is out of a 47 document. It's a transcript of discussions. And Captain Hutchinson is talking about how to learn more about long trends in the changes of the climate. This is following Allman's visit. There are a few researchers who are really promoting this. I find this one particular exchange intriguing because it gets, I think, at that question of the production of knowledge, how certain anyone can be about new results emerging. Paul Seipel, famous Arctic explorer, skilled in a number of natural science disciplines, is a member of that board. He asks the simple question, are we going to consider biology? And the first reaction is, yeah, we're going to try to pull that in. Seipel presses, and the response comes back. The phase of botany and biology in general phases are not covered in any way by this board. Their understanding that the knowledge they're aiming to produce is limited. A few people are pushing back. It doesn't change the overall direction of what the RDB does. I want to transition in a moment to a few quick stories, but tell, first of all, what some of the impacts, what occurs because of the military's interest in these phases of environmental science. New institutions get created, new people are trained. I'm sorry, this is a little bit small, but one of the key figures in the RDB says we need soon at least 350 new Earth scientists in order simply to fill the open positions for the research that we need to get done. The money goes to the Naval Arctic Research Lab, but even more because the recognition is clear. The knowledge is going to be produced at universities, by and large. And so the funds start to flow to established institutions, new ones that are just being created, where Allman spoke in Los Angeles. That was a new Earth Sciences entity. But I want to focus here quickly on just two of those facilities, Scripps and Lamont, which is at Columbia University. I suspect these entities are familiar to many of you in the moment. Scripps, the website as of last night, advertising the research it does broadly in the environment. It had long been in both the physical and the biological branches. It was at Scripps that Roger Revelle, the Earth scientist, writes a famous paper, 1957. You can see the argument he's making out of the evidence that's emerging. He is one of the first to talk about human-caused, industrial age climate change and the impact that can be coming. Scripps gets not all but some funding from the military for its larger research. Helmuth mentioned the International Geophysical Year. Roger Revelle was quite active in it, the IGY. 66 nations, tens of thousands of scientists, still one of the largest activities of this kind ever developed. It was the start of the space age, also in the IGY. Revelle was able to get funds to a young researcher named Keeling. He put a small observatory at the very top of a mountain, volcanic mountain in Hawaii, Pacific Ocean, relatively clean air, to try to measure was carbon dioxide levels in the atmosphere changing. That famous curve is coming out of the push to get this kind of research done. That's the Keeling curve, starting in the IGY. Let's turn quickly to Lamont. We can see the founding director over there on the right-hand side. Lamont has a different history than Scripps in that it is new, it is founded in the early Cold War period, and over 90% of its funding is coming from military entities in its first decades. Lamont is physically separate from the Department of Geology at Columbia. It's officially connected to it. The distance allows very intriguing cross-disciplinary alliances between geochemistry, geophysics, other branches of the earth sciences. One of the young doctoral students who stays on is Wally Broker. Some of you will know him for the work he's done on oceanic circulation, but you may also know him as the one who coins the term climatic change in a paper in 1975. He's working on these issues from the time he's writing his dissertation in the late 1940s. These institutions created through the Cold War funding for utilitarian reasons are pursuing questions that include what's going on with the atmosphere. And these are places, incubators for graduate students who also have freedom to explore these ideas, sufficient funding, some of it from the military, as in the case of Ken Hunkins on an ice island, feeling like Alexander von Humboldt, able to explore a wide range of questions. I'm going to conclude with 3 short stories and then, bless you, and then some larger issues, themes that I think comes out of this evidence. But this declaration by the Department of Defense, the Pentagon, in 1961, an interesting year, when the Department of Defense is saying it has an interest in the environmental sciences, they mean the physical parts. They're not thinking of biology. It's coming out of this long now tradition of research at the Pentagon, and it is why Horning, when he is sharing with Lyndon Johnson and others views of what the environmental sciences involve, that it's the physical, not the biological, that are getting stressed. So when did these bits of knowledge come to be communicated to political figures, people who had other kinds of authority to make changes, to sponsor additional research? This was something I included in part thinking about the junior colleagues who are here who might want to take on an area of research in this field. This is something that isn't going to be in the book that I'm writing on this theme. I don't think it is out of the Canadian archives. It was a chance discovery I made. It's a letter, 1952, from an Arctic researcher to the higher levels of the government in Ottawa. I mentioned to you that the thickness of the ice in the north has been decreasing very rapidly. Now I've got some figures, and he gives the figures. He concludes the letter by raising this as a policy issue, as a larger broadening into humanitarian concern. If an open polar sea emerges in the next decades, it is going to have enormous economic and strategic implications. And you see the scribbles at the bottom. The letter is going back and forth throughout Ottawa. What's going on? We don't know yet. But I think the possibility is growing. There he is, by the way. That this next generation of researchers will be able to get more of these archives open to explore stories that haven't yet been told about how people came to know about climate change and how others began to react to that news. This is out of the U.S. National Archives. Yeah, it's stamped secret all over the place, but the good news is that all of those have just recently been declassified. There's a lot that people can now get into that has just begun to appear. The second of the three short stories before finally wrapping up, different kind of question. How early did U.S. presidents, the White House, that one part of the political system that could have enormous influence on what got done, what got funded, how early did climate change become a concern at the White House? We know both from the records in the Carter Presidential Library that Jimmy Carter was quite concerned about climate change as part of the larger energy issue that he was confronting in his presidency. How did he know? He had as a science advisor, that's that same figure, Ewing, who ran Lamont. This fellow hanging on for dear life over here on the left is Frank Press, who becomes Jimmy Carter's science advisor. He takes that deep knowledge of what's going on, and it informs the Carter presidency. We know from recent archival findings that Lyndon Johnson had heard directly about this from Roger Revelle at Scripps, who had come to be an advisor in Washington. But how about the Kennedy administration? It's been a hidden story. In many respects, it still is, because of the continued classification of the records of Kennedy's own science advisor. You're seeing him here, Jerry Wiesner. And the highlighted one, Atmospheric Sciences, closed. I've been working with a documentary crew that is exploring how people discovered climate change, and they're also looking at how historians are discovering what was known when. And we put in a declassification request. The good news is 600 pages are available. The bad news, the facility that holds them is still closed because of COVID. The archivist there was kind enough to send one scan from that 600 pages, and you can see what intrigued him. It's not that this enterprise wasn't known, but the emphasis on forecasting, foreseeing climate change is not as well known in the literature that is available. And I think Kennedy, John F. Kennedy and the administration, is a story that still needs to be carefully threaded. Kennedy issued a strongly worded statement, an action item to all the members of his cabinet. If you're doing anything to the physical or the biological environment as an experiment, you let me know first before it's going to be approved. Yes, it's occurring at the same time as the major atomic tests are still going on. Kennedy's negotiating involved in what becomes the Limited Nuclear Test Ban Treaty. But it's also Kennedy who mentions his awareness of the work of Rachel Carson. There seem to be threads that have not yet, I suspect, been as well explored as they might. And these new documents may begin to tell a story of how the Kennedy administration was also treating the challenge of climate change. Be prepared, however. These are documents from 1951. They are still classified. They could be telling very interesting stories. It's going to be a while until we know. Finally, environment as a national security policy issue. was thinking first about Kennedy because a key document only appears in April of 1960 in 61, and the later drafts of it, but it is emerging during the Eisenhower administration. It's a CIA document, and the title of it, sorry if it's a little hard to read in the back, Environmental Research and its Implications to Long-Range Power Positions. What are they concerned about? The Soviets know so much about not only the Arctic environment, but also the physical environment of the entire Earth. It's an element in the power struggle between East and West. Soviets have an advantage to gain a capacity well beyond that of the West. The developments are meant to increase Soviet, you can read it here, economic requirements, global scale issues. It's an accurate assessment that the Soviets know a lot more than the US does about the Arctic, and that in contrast to the United States, which has done this work as an aspect of military concern, the Soviets are doing it in the long haul. They're going to have an advantage. What does this mean that this is at this level of discussion? Indeed, the IGY makes it possible for people to communicate, to recognize the strength of Soviet science in the West, which hadn't always been appreciated. The structure of Antarctica came about because of the work of Earth scientists making it possible to consider it in an alternative to territorial way. But there's some hints just emerging in the archives that this is part of a long continuing discussion in the Eisenhower administration to look at key strategic issues. Diplomatic historians would talk about, say, the new look that emerges in the beginning of the Eisenhower administration policy towards national security. This seems to be a continuation of it, and now it's not atomic weapons that are being nominated as particularly crucial, but environmental knowledge. We don't know yet, I think, enough about how well that was received, whether it was considered a minority view. We don't even know who wrote it. But it's there, and it's part of those stories that I think we can tell. 3 final points, and then let me be quiet. The one underlying point, and it's come up in many of the good discussions we've been having, is how limited knowledge was of what was happening in the climate in the period that we're talking about here. Yes, more scientists sensed 65 through 79 that the Earth was warming than cooling, but other data, including what was coming out of research into old climate change, didn't come until the late 60s, earliest, then the 70s and the 80s. This, I think, is particularly important. Here's the start of this discussion. It's been warming, and then there's an interregnum. Then it warms again, but it reduces concerns about whether the climate is really changing for this crucial period of time in the early Cold War. Helmut anticipated, we didn't have a chance to talk about this before, but the way in which, how do we tell stories about the factors that came to allow a recognition of what we're putting under the term Anthropocene? How do we look to national security and the production of knowledge, not for sustainability, but for utilitarian ends that still creates the robust research institutions and the robust data that are at the very heart of what we know of particular long-term environmental issues. Finally, let me end. You remember it was 61 that the Pentagon was talking about knowing the environmental sciences, the physical environmental sciences. It was just a year later that Silent Spring appears, that transformation, that story. And part of the challenge I have is how to tell that story that is about a term called environmental sciences that means something quite different to us in the moment than it did back when this group of researchers felt invested in the environment but were asking very different kinds of questions. One result simply, if we look at the environmental sciences as a whole, the production of knowledge was not equal from the physical to the biological branches. Understanding the shape, the gravity of the earth got to be known to several post-decimal points. But as Carmel Finley, in her own work done here, has helped demonstrate, understanding how many fish were in the sea was something that was very difficult to gain knowledge of in the Cold War. That's the story, and I would love to hear any reactions. Thank you all so much.